All right, our next song is Wonderful Tonight by Eric Clapton. Love this song. And we're going to take a look at another absolute value inequality. So again, our first step is to isolate the absolute value. So I'm going to divide both sides by -5. And that flips the inequality when you multiply or divide by a negative. So now we have a greater than. So let's think about this. Again, I'm going to start with a more simple example. Let's say the absolute value of x is greater than or equal to 3. We'll just simplify the insides a little bit. What values would make this true? 3, 4, 5, 6. All of those would make it true. Not 2, not 1, not 0, -1, -2 wouldn't work. -3 would, -4. So I'm going to start to graph some of my solutions. We talked about 3, 4, 5. We said from 2 to -2 wouldn't work, but at -3 and -4 and -5, all of those would work. So this looks to me like an OR inequality. So I'm going to go back to my original inequality, drop the absolute value. First one is absolutely normal. The second one, same thing. Last time when we dropped the absolute value, we flipped the inequality and made it negative. So look at our little graph here, less than or equal to. The inequality got flipped when we got to the negatives. So we solve each of these by adding 3 to both sides. And we have x is greater than or equal to 6 or less than or equal to 0. Less than shades left. And solid dots because we have the or equal to, greater than shades right. Last example, we've got a little word problem. We're going to be setting up our own inequality. I know you guys know how to read, so go ahead and pause for a second to read the problem. And we're going to solve this with our UPS check. Lots of numbers in here. Most of them we don't need. The year the Earth was traveling doesn't matter. The day it was closest and farthest from the sun doesn't matter. What matters is the distance. That's what we're looking at. So I'm going to look at 91.4 million as being the closest and 94.5 million as being the furthest. We need to set up an absolute value inequality. So to plan this, let's just start to generate some ideas. And since I'm the only one talking here, I'll just generate the ideas myself. So I'm thinking about the fact that I'm thinking the difference between the two numbers might be important. So I'm just going to jot down a few ideas as I'm brainstorming the difference between the two distances. And I'm thinking the halfway might be helpful as well. So now I'm going to attempt some sort of setup and we'll see what we come up with. So I'm going to go ahead and figure out these two values that I thought might be important in my planning stages. The difference, so 94.5 minus 91.4 gives us 3.1. And the halfway distance, so when the Earth was the halfway distance from closest to furthest, so that would be cutting the 3.1 in half and adding that back on to the smallest distance. Okay, so now we need to set up something with all of these numbers. We've got the 3.1 million is the difference, okay? 1.55 million miles is the halfway. The actual halfway distance was when the Earth was 92.95 million miles from the sun. All right, so we need to throw this in some sort of absolute value. And I'm thinking a less than or equal to because the Earth will be traveling between these two. So to me, I'm thinking a conjunction. So if we take the distance that the Earth is from the sun minus the halfway distance, the absolute value of that needs to be less than or equal to this halfway distance from the closest to the furthest. And then let's check. Let's substitute a few numbers in. I was just kind of throwing out some ideas and putting them in an absolute value, and let's see what sticks. So we know that the Earth was not closer than 91.4 million miles. So let's see what happens when we substitute 90 million miles in. The inequality better not be true. If it's true, we did something wrong and we'll have to go back and fix it. So let's see what happens. I'm going to put a little question mark because we're checking. And if I do 90 minus 92.95, I get 2.95. The absolute value of that, of the negative 2.95, is not less than or equal to 1.55. So far, so good. Now we want to pick a distance in between the 91 and the 94. So let's go with 92. That seems to be an easy one. Put another question mark. And the distance here is 0.95, which the absolute value, yes, that works. So far, so good. And let's pick a distance like 95 million, where we know the Earth was never that far. And when we subtract, we get a little over 3. A little over 2, but that's still bigger than the 1.55. But this checks as well because we didn't want it to work. All right, and finally we have our U-try problem. So go ahead and jot these down.